Hello, it's time for Khan Academy number 11 in this series. Use geometric sequence formulas. Okay, as soon as I make my head the requisite size, which I'll probably have to shrink later because it'll be in the way, we'll get started. Okay, so right now we are in geometric sequences, which I drew a geometric sequence right here. It's a series of numbers in a specific order, and it has a starting number, 3/2, and a common ratio, which is times -2. So I tried my best to write times -2 repeatedly here. So if we take 3/2 and we multiply it by -2, we multiply that by -2, you can see that the sequence goes from positive to negative and increases by -2 each time. That sequence is also represented right here as a of n equals 3/2 times the quantity -2 to the n minus 1 power. Now, that is a lot. There's a lot going on there. That's an explicit formula. And I want to just remind you that as we work through this, we're going to be using the high school level of PEMDAS, order of operations, which I call GERMDAS. And GERMDAS for me stands for any sort of grouping symbols. That's the G. Exponents, like in PEMDAS, we had parentheses exponents, and I'm thinking exponents has an opposite operation, radicals. And then we're going to do the multiply and divide, add, subtract from left to right. So what we'll see as we look at this Khan Academy right here, this type of problem is going to show up, as well as some recursive formulas. So I've done a couple of each in this Khan Academy video. We are looking for the third term in this sequence. Now, if somebody was nice enough to write out the entire geometric sequence for you, then you could just simply say, well, the third term is this. It's 6. The first term, second term, third term. So we know already the answer is 6. And the question is, well, how do we do that repeatedly? What are all the tricks that get us to doing that if somebody wasn't nice enough to write out the entire sequence for us in the first place? And that's what we're going to do. Okay, so let's go ahead and just look at this. This, again, is function notation. Um, the top of this table is our n, our numbered terms, our first term, our second term, our third term. And this is our a of n output. So our first term is 3/2. Our second term is -3. And so as I read this, I'm reading a of n equals 3/2. Now, for me, being a math teacher, I know that within this explicit formula that this is where my starting term goes. So I know that's my first term. And I also know that this -2 here is what's going to end up being my common ratio, or what I like to call the constant multiplier. So I'm looking at that and I'm drawing information out of the formula. We will learn how to do that in the future, but for right now, I'm just sharing with you what I'm seeing as I look at this, one of the very first problems within this particular Khan Academy. Okay, so how do we actually answer the question, get to 6 without having all of this done for us? Well, what I'm going to do is I'm going to start rewriting this here, and I'm going to be writing this arithmetic sequence with a third term with a 3 plugged into it is going to return to me 3/2 times the quantity -2 to the n. My n was 3, so I'm going to write 3 minus 1. Okay, that's a lot. It is a ton of information. And what I need to do is I need to work through all of this math using my order of operations. And PEMDAS, that abbreviation, just doesn't cut it because there's no parentheses here with the 3 minus 1, but there's an understood grouping symbol. So I changed PEMDAS to GERMDAS because of things like this. What I'm going to do is I'm going to step by step my way through this. I hope my pen tool is not allowing me to scroll. There we go. got like 3 mouses for this laptop that I'm recording these on. And I'm going to just understand that one of the grouping symbols I have to know exists in the world of algebra is in these exponents. So according to order of operations, the very first thing I should do is I should work on this, what's inside the grouping symbols. 3 minus 1 is easy. That's just 2. So now I am left with this information. As I think about order of operations once again, I just tackled my grouping symbols. Now I'm moving on to exponents and radicals, the E in PEMDAS or the E in GERMDAS. And so that's telling me that I need to next consider -2 squared. So I'm going to evaluate -2 to the second power. Now, -2 squared literally means -2 times itself. Negative times a negative is positive. So now I'm dealing with 3 over 2 times 4. 3 over 2 times 4 can be thought of mentally as a fraction times a whole number over 1. I could multiply straight across. 3 times 4 is 12. 2 times 1 is 2. And then divide. 12 divided by 2 is 6. Dun, dun, dun. We got an answer. The answer of 6 was the answer we already knew because I had written out the sequence previously. However, we also could use order of operations. Now, I'm going to be the first to tell you, I don't always do this. I've got this, which is my little calculator. I've got this, which is my phone calculator. And I don't even stop there because I like me some calculators. Boom, here it is on Desmos. And you'll see that I actually typed it in. 3 over 2 times -2 to the second power, and out pops 6 for me. So I'm using Desmos calculator. I'm using my phone calculator. I can do it by hand. I can flex with my math ability, but a lot of the times I'm not actually doing that. I'm actually just using a calculator. Okay, so what were the basic skills we needed? We needed to be able to read this information. We needed to be able to write the basic arithmetic sequence. Oh, I said arithmetic, the geometric sequence with the third term in the correct spot. And then we had to do order of operations. Okay, so explicit formulas is one type of problem that you're going to have on this Khan Academy. I'm calling it number 11, use geometric sequence formulas. The other type is the recursive formula. So we've seen the recursive formula in arithmetic sequences within the series, but we haven't seen it in geometric sequences. So what I'm going to do right now is I'm going to interpret this information for you, just as soon as my mouse allows me to click on the pen tool. I command you, uh-oh, it froze on me. Maybe you can see me trying to click on it. Oh, there we go. Okay, so I'm reading the recursive formula right now. The recursive formula says a of 1 is 20. That means my first term is 20. What happened there? Come on now, is 20. And this says a of n equals a of n minus 1 times 3 over 2. So what this means to me is that if I was calling this term right here a of n, then the term before it, and we've seen this in this series, the term before it, this term, we could call a of n minus 1. It's that numbered n term, which in this case is 6, minus 1, the fifth term. So I'm reading this as a new term is equal to the previous term times 3 over 2. And so what that's telling me to do is to think of this as times 3 over 2 over and over and over again. We call that our common ratio, or we can call it the constant multiplier. I'm not going to keep rewriting that. You get the picture. Okay, so I'm looking at this Khan Academy. This one gave me a recursive geometric sequence, and it wants the third term. So it's basically asking me, what's that number right there? It gave me the first term, 20, and so what I'm actually going to do is multiply times 3 over 2. 20 times 3 over 2 is going to be, I'm going to put this over 1. I'm going to cross simplify, and I'm going to get 30. I'm going to write that in a different colored ink. Okay, and 30 times 1.5 again is 30 times 3 over 2. Again, I'm going to put this over 1. I'm going to cross simplify, and I'm going to get 15 times 3 is 45 over 1, or 45, and I'm going to get that answer of 45. It asked for the third term. I started with the first term, and then I followed this recursive formula, times 3 over 2, times 3 over 2, and I finally got the answer of 45. Okay, so there's two types of problems within this Khan Academy. There is the explicit formula, where you can jump to any term within the sequence, and that's the power of the explicit formula. You want the third term, I'll go straight to the third term. You want the 99th term, I'll go straight to the 99th term. Whereas with the recursive formula, you always need the number before it. So I couldn't jump straight to the third term. I had to find the second. And before I found the second, I had to think of the first. So we have to kind of slowly and incrementally move up within the sequence. Okay, since Khan Academy asks us to do both in this particular set of exercises, I did create an explicit formula and an arithmetic formula one, and then I did even another set. So you can sit back and watch if you need more examples, and have a calculator out because it may help you. Okay, so moving on. This says b of n equals -1 times 2 to the n minus 1. Find the fifth term. So I'm going to be writing here b of 5 equals -1 times 2 to the 5 minus 1. And I'm just going to do this mentally. So instead of writing 5 minus 1, I just wrote the 4 here. Okay, so this is -1 times 2 to the 4th power. Again, I'm using GermDOS order of operations. 2 to the 4th power is it 16? It is. 2 to the 4th power, I can't find my webcam, is 16. So I just used my calculator to get this, and then -1 times 16 keeps me in order of operations. Exponents comes before multiply, and I know -1 times 16 is -16. So that's the fifth term of the sequence. You'll notice when I do the explicit formulas, I'm not using the table. However, when I am using an arithmetic sequence, it really helps me to use that table. So you might want to write out something that looks a little like this table on a scrap sheet of paper. B of 1 is 15. Okay, so I'm coming up here to 15. And a new term is equal to the term before it times -3. So I'm reading this and I'm thinking, okay, I'm just going to be multiplying -3 every single time. It wants the fourth term of the sequence. So I know that I'm going to stop when I get here, and that's going to be my answer. So I'm going to type into my calculator right here, 15 times -3. That gives me -45. I'll choose blue for that. And then I'm going to multiply that number times -3, and that gives me positive 135. Why aren't you writing? I command you. My laptop. Oh, there you go. It's been a little slow today. Okay, so we're going positive, negative, positive, and that's what happens when you continuously multiply by a negative number. And times -3 again, and I get this -405. It asked for the fourth term. I built up because I'm doing arithmetic formula work, and I got -405 as my final answer. Okay, two more just like that, and then we are done. Explicit formula, what's the second term? So I'm thinking this is going to be C of 2 is going to be -9 over 2 times -4/3 raised up to the 2 minus 1 power. 2 minus 1 is 1. And then when we raise something to the first power, we don't really change it at all. -4/3 to the first power is simply -4/3. So I am now just dealing with this -9 over 2 times -4 over 3. And again, I'm going to cross simplify. I'm going to say 3 divided by 3 is 1. Negative 9 divided by 3 is negative 3. 2 divided by 2 is 1. And negative 4 divided by 2 is negative 2. Now, if that doesn't make you happy, you can always just put those into Desmos or put those into a calculator. Negative 3 times negative 2 is positive 6 over 1. And so I'm thinking my answer is 6. And just to double check, I'm going to put that into my calculator. Negative 9 over 2 times negative 4 over 3. And where's my webcam? There it is. You can see that I used the ABC button on the calculator. I typed it in and out popped 6. So there's my double check. Okay, for the arithmetic sequence, I'm going to begin with a of 1 equals negative 11. So I'll put my negative 11 right there. The new term is always the previous term times 10. So that's telling me that I'm going to be multiplying 10 over and over again. And the question says, what is the fourth term? So I know I can stop when I get to here. So when we multiply by 10, we're just adding a 0. So negative 11 times 10 is negative 110. Negative 110 times 10 is negative 1,110. And then this looks like I'm going to have one more 0, and that's a negative 11,000. So not too bad, as long as we can read and understand what this is saying to us in this arithmetic formula. Okay, 2 more. Oh no, we're done. We did them all. Yay, we're finished. Okay, so there's some explicit and arithmetic examples. Oh, I used the word arithmetic, didn't I? I meant to say recursive. These are not arithmetic. These are recursive. Sorry, I used the wrong word. There, I fixed it. I hope that didn't bother anybody. Take care. Bye.